Hi there, it's Matt here, and welcome back to a new episode on what I think may be one of the most exciting fields in sleep science that has just exploded on the map, and it focuses on a topic called antioxidants. Now, I say it's a new field, but if you actually go back into the literature, what you'll find is that there is a theory proposing a link between sleep and antioxidants that dates back all the way to the 1990s. You probably were thinking I was going to say something like the 1700s or something like that, but it's the 1990s. That was a little bit before my time in terms of being a scientist. I think I was only around 10 years old at the time, but I'm dating myself. But focus, Matthew. This is not about you. This is about the listeners and the episode. Now, to understand the relationship between sleep and antioxidants, and even before we discuss that theory, we should probably understand what antioxidants are and what they're trying to target. Because antioxidants are there to combat their nemesis, and specifically to deal with molecules that are called free radicals. So we're first going to focus on why free radicals are relevant to the topic of sleep and therefore why antioxidants are relevant. And specifically, we'll understand what role that free radicals play in the deadly consequences of a lack of sleep in the extreme. And I do quite literally mean deathly, as in life extinguishing, life ending in terms of a consequence of sleep loss. Although I should say that I don't mean to sound too scaremongering in this regard. I want to firstly recognize that, of course, all of us have had periods in our lives where we don't sleep enough or we're sleeping too little for whatever reason. And whether that's studying for an exam or racing towards a big work project deadline or just that we've had a bad night of sleep, obviously that lack of sleep feels miserable and terrible, and there are consequences to that we've discussed on this podcast. That's not what I mean when I speak about the deathly consequences of sleep. Here we're talking about sleep deprivation in the extreme, leading to the mortal consequence, the deathly outcome. What we know from studies by scientists that were conducted, some of them 50 years ago, 40 years ago, is that a lack of sleep in a number of different species will lead to death. And scientists have conducted experiments in things such as cockroaches, in flies, in rats. They've even done those studies in dogs. I know. I cringe at that idea. But what we've definitely discovered is that in all of those species, when taken to the extreme, sleep deprivation does lead to death. But the question was why? Why does a lack of sleep have these deathly consequences? What is the mechanism? What is the cause of death? Now, certainly what we know is that in many higher order species, that sleep as a process is generated by the brain. So obviously the thought was that perhaps the brain is where some of these deathly mechanisms play out. Perhaps that is the scene of the crime. And our sort of CSI forensic examination should target that as the first crime scene. But when we examined the brain, there was nothing obvious in those different species. And when we examined other parts of the body, other major organ systems, for example, such as the cardiovascular system, including the heart, or the immune system, or the thermoregulatory system, which it turns out is actually critical for your survival, none of those things could help explain why those species were dying. And this brings us back to the story of free radicals and oxidative damage. A sponsor of today's show is Inside Tracker, which is a service that comes out to your home and they will analyze your blood and your DNA to know precisely what is going on inside of you. Hence the name Inside Tracker. They look at your blood, your metabolic signals, your hormonal health metrics, and then they give you a personalized actionable set of lifestyle changes in response to that readout. And the goal there is to improve your health. I was looking and informed they have some new cardiovascular and new hormonal biomarkers that I'm particularly interested in. One that I'm focused on is something called ApoB, which is an absolutely critical heart health measure. And I get it done now with them somewhere between 4 to 6 times a year. Why? Well, my family unfortunately has a strong history of cardiovascular disease, so I am checking that pretty ruthlessly. And by the way, I do buy the product myself out of pocket. I don't want to fall prey to any of those trappings and undue incentives. Although, with full admission, I still use my own discount code that you can use to get some money off. And that code for you is insidetracker.com/Matt Walker. So just go over to insidetracker.com/Matt Walker. And again, if you want to get that discount, it is insidetracker.com/Matt Walker. Thanks very much. So many of you, I suspect, have heard of this term of free radicals. And to understand what free radicals are, we have to understand what molecules look like in your body. And all of those molecules will have a cloud of electrons floating around them. And it's quite the romantic tale because those electrons floating around those molecules in your body, they come in pairs. They actually hang out as a couple. It's desperately sweet, isn't it? But occasionally the romantic status of these molecules can be unbalanced by an unwelcome third wheel, to stretch the metaphor completely inaccurately. And what I mean by this is that some molecules can all of a sudden gather an extra electron. And as a consequence, it's what we call an unpaired electron. So you've got those pairs of electrons that are circulating like a cloud around the molecule, but then occasionally there will be an unpaired electron in there. And sadly, that unpaired electron is not at all well behaved. That extra unpaired electron is a troublemaker. It's a bad actor. And what it creates is this thing called a free radical. To be clear, I should note that free radicals are a normal byproduct of life. We all create them inside of ourselves as part of the natural energy cycle. However, if your levels of free radicals get too high, they become a serious problem, as you will learn in this podcast. They will start to steal electrons from other components in your body, from things like proteins or fats in your cells. And basically, they will start to break them apart. And a good example of the type of damage that they can lead to is a damage of the nucleus inside of your biological cells. And particularly what they will damage is the genetic material that we call DNA. One of the things, therefore, that those free radicals will do is damage the DNA. And when the DNA is damaged, it causes mutations, and those mutations lead to disease and sickness and disorders. Now, since free radicals are, as I said, a natural part of the energy process, the energy cycle, your body has some built-in mechanisms for dealing with these free radicals. And that is where those things that you've also heard about come in, those things called antioxidants. And those naturally occurring antioxidants in your body will neutralize the free radicals. And as you'll remember, a free radical is created when you have an unpaired electron, and that makes that molecule unstable and it starts to do damage. The way that antioxidants work, in part, is that they're immensely generous. They are gift-giving. In fact, what antioxidants will do is donate. And more specifically, they will donate an electron to those free radical molecules. So now, instead of having a stray unpaired electron that is causing all of that trouble, The electron cloud of those molecules is now returned to romantic equilibrium. And because all of the electrons are now paired by equal numbers, 2 by 2 by 2, the molecule returns to a stable state. And now it is no longer doing any damage. Order has been restored to the molecular universe of your body. I will come back to this in another episode, but as I said, your body produces a natural set of antioxidants, but you can also consume them. And you consume them in your diet. They are present in things like blueberries and pecan nuts. And I also believe that they're present in dark chocolate for the chocolate lovers out there. I'm actually not a chocolate lover. I don't know what's wrong with me. Well, there's a number of things wrong with me. Not liking dark chocolate is the least of my troubles. Anyway, when we talk about free radicals and the damage that they do, we scientists and also in medicine have a term for that. The damage that is caused by free radicals is oxidative stress. And that oxidative stress caused by the free radicals does damage to your cells, damage to your organ systems, and as a consequence, it can significantly damage you, the organism. And at this point, you may be saying, this is great, but I tuned into this podcast to learn about sleep, not necessarily free radicals or molecular biology. So can you please get to the sleep component? What does all of this have to do with sleep? Well, believe it or not, it touches on a very fundamental question. Why do we sleep? And why did sleep evolve in the first place? This brings us back to the 1990s and the theory that I mentioned that in some ways originated this whole field. The man who came up with the theory was called Eric Raymond. And in 1994, he published a theory paper. That theory paper was called the free radical flux theory of sleep. Let me say something here first. How bloody fantastic is that title? The free radical flux theory. I mean, if you're going to start a band out there, if you're listening right now, you're thinking we should start a band or about to name our next album. Can you please call yourselves Free Radical Flux or something like that? It's absolutely brilliant name. Anyway, Riemann published his theory, and it was just that at the time, almost 30 years ago. But the theory set forth that perhaps one of the reasons that we need to sleep in some ways is to deal with these free radicals that build up. And particularly since those free radicals may be building up during the more active state of wakefulness. And it is sleep, and perhaps the reason why we evolved sleep in the first place, that those free radicals are returned to a normative, safe baseline level when we wake up the next morning. So in other words, sleep was our salvation from the damage that free radicals could potentially do. In the past 30 years, then, has there been any evidence to support or reject the theory? Well, strikingly, it was only recently that a research group at Columbia University in New York explored this theory in really granular fashion in a way that it's never been explored before. And those findings are utterly striking. The researchers were studying a mutant strain of fruit flies, and those mutant fruit flies didn't sleep very much. And if you want to know the genetic name of those fruit flies, it's incredibly creative. The strain is called sleepless. I know, we've got to do better in sleep science. This podcast is supported by Athletic Greens, which is now known as AG1. AG1 is a comprehensive nutritional drink that contains countless key health components. Actually, let me stop there. I say countless, but I actually know the company. I know how the product is made. And I believe at last count, it's over 75 different vitamins, minerals, probiotics, prebiotics, and other whole food nutrient sources. I do drink AG1 every day for the record. And also for the record, I buy my own supply because of all of the obvious integrity trappings that come with the free product. I know the company well, I know how the product is made, and I genuinely trust in their manufacturing. They are registered and approved by the Therapeutic Goods Administration. They also have GMP stamps, which means Good Manufacturing Practice badges. Basically, they're rigorous. So if you'd like to pick up an offer and get some money off your first order and also get some free travel packs, just go to the link drinkag1.com/Matt Walker. So that's drinkag1.com/Matt Walker, and you will get some money off your purchase. So again, last time, that is drinkag1.com/Matt Walker. In truth, I do also use my own link to try and get some money off. I do buy it myself, but I do use the link to get that code money off too. And you can use that link as well. Thanks very much. So what they wanted to understand was, what are the major biological differences in the group that was a short sleeping subset, which is the mutant group, versus the normal fruit flies, which sleep a normal amount. And so they started off looking, for example, at the immune system, and they found no difference between the two groups whatsoever. Both of those groups reacted the same way to, for example, a bacterial challenge. Then they looked at the metabolic system, and they wondered whether there was a difference there. Perhaps the short-sleeping flies would struggle with their ability to manage energy or expend energy. And there was no difference there either. In fact, both of those groups had the same survival rates. In other words, they both died as quickly from starvation from food. And then they kept looking at different systems and kept failing to find a difference, until they started to look at free radicals. And using another manipulation and a specific herbicide that would create high amounts of oxidative stress, what they found is that those short-sleeping fruit flies were much more vulnerable to the impact of free radical damage. They were far more likely to suffer that catastrophic oxidative damage caused by the free radicals relative to the normal sleeping flies. Yet in science, what we typically like to do is try and demonstrate bidirectionality in terms of causal manipulations. So what the researchers had done there is demonstrated that when you dial sleep down, you will causally increase oxidative stress and vulnerability. But what you would also want to do is the opposite. What would happen if the researchers were able to dial up sleep? Could you causally decrease oxidative stress vulnerability? And that's exactly what they showed. Here, once again, they used a genetic trick that flipped the switch to make those flies start sleeping extraordinarily longer amounts relative to the normal sleeping flies. And those longer sleeping flies suffered far less oxidative stress as a consequence. They were far more resilient to the free radical-induced damage caused by that herbicide. This was a landmark study. It taught us something rather profound that we'd not truly grasped before. It indicated to us that perhaps one of the reasons why we sleep, or at least one of the reasons that flies sleep, is to manage this thing called oxidative stress caused by free radicals. In fact, it was such a striking finding that what it led to was the proposal that one reason that sleep evolved in the first place was to deal with something that is universal across all living species, which is the creation of free radicals and the need to manage the burden of those free radicals. And on this basis, we were able to go all the way back to Riemann's theory, the free radical Lux theory, all of those years ago. What that suggested is that we in sleep science have perhaps missed an essential elemental reason why sleep evolved in the first place. One function of sleep, perhaps the principal function of sleep, was to mop up the free radical burden that occurs within ourselves each and every day. Almost like a sort of an overnight cleanup of a massive toxic oil spill. Although, of course, it's not oil that we're talking about here. It's those third wheel free radical troublemakers. But it turned out that's not the end of the story either. As I said at the start of this episode, we've known for some time that severe sleep deprivation in numerous species results in death. And I also told you that scientists have consistently struggled to come up with any crystal clear explanation as to why. What is it about not getting enough sleep that is so mortally life-ending? That is the question I will address in the next episode. And I promise you that the results will be utterly remarkable. And more than that, the way that you can prevent death that is normally caused by sleep loss is even more striking. But until then, I will wish you a full night of free radical mopping up sleep. Take care and goodbye for now.